Okay, thanks very much. Firstly, thank you for turning out to listen to our talk today, to learn a little bit about our journey in terms of how we've enabled DevOps and SecOps for, well, as you can see, over 20,000 applications, and it has been a bit of a ride. I'm going to say an apology up front. My voice feels a little bit croaky. Part nerves, part the fact that if there's any speakers out here in the audience, we had a speakers dinner last night and may have had the odd glass of wine, so you bear with me. Right, so let's get underway. What I'd like you to do is imagine a world where at the click of a button, as a developer, you can release a valuable feature or intent into your organization, but having the confidence that when you do that, it's both secure, compliant, it's tested, and it can be trusted. Well, that's not an impossible task, right? Well, actually, it depends on the size and scale of your organization, and actually some of the controls that your organization might demand. Over the course of the next 40 minutes or so, we're going to try and take you on a bit of a journey that Capital One has been on for the last few years. It's almost what we determine the holy grail of building a CICD common pipeline to service over 20,000 applications across our entire organization globally. A warning, there's a little bit of audience participation halfway through the session, nothing to worry about, but I thought I'd get that out there. Right. So I'm Chris Richardson. I'm one of the senior engineering managers at Capital One, and I'm responsible for leading teams that build the developer tooling and some of the cloud foundational infrastructure that really ensures that our engineering teams can be as successful as they can be in providing all the valuable features out to our customers.
Hi, I'm Paul Jackson. I'm a software engineering manager in Chris's group, and I lead a team that contributes to that platform and additional dev tooling as well.
Thanks, Paul. Brief intro into Capital One. So for those of you that may not be familiar with Capital One, I've been hanging around on our booth in the expo hall for the last day or so. I've asked a few people, do you know Capital One? Do you know who we are? What organisation? The responses have been reasonably positive. Something to do with finance. Are you a bank? Actually, all that's correct. So it's looking good. But for those in the audience that think we're a London-based radio station, Capital FM, no, I'll dispel that myth, we're not. So at Capital One, it's our mission to change banking for good. You might know us as a credit card provider in the UK, but really we're a financial services company with technology at the heart of our business, which is really important. We're driven by making finance simpler and more human for our customers, and that actually makes Capital One quite an exciting place to work. You can see by some of the data on the screen, we were founded back in 1994 by Rich Fairbank, and Rich is actually still in seat as the chairman of the organisation today. In 1996, we came across to the UK, and multifaceted, so we have retail banking, we're part of auto loans, and obviously credit cards too. The US headquarters for the organisation is located in McLean, Virginia, and we have office space in the UK, both in Nottingham and also in London. And you can see on the slide there the London office, white collar factory in the Silicon Roundabout in Shoreditch, just down the road, 10 minutes away. Over 50,000 employees globally. But why am I telling you this information? Why is it important? Well, it's to give you a sense of the size and scale of our organisation. It's fairly vast. It's spread across multiple countries. And as you probably know, this in itself can create many challenges for tech teams to be as efficient and effective as possible. The way in which we build and deploy our software and iterate on it, it needs to be consistent for our business success. So, first, let's take a little look at the timeline of Capital One and a bit of the tech journey that we've been on over the last few years, because it'll help build the picture. So way back in 2015, we transformed our entire organisation, like many did, fully agile. In 2016, leveraging some of those agile practices, we started dipping our toe into the public cloud, and some of our first production workloads were launched way back in 2016. In 2017, there was a huge, heavy investment that we made in software engineering talent, and that was really fueled by some of the external hiring that we did, and also some of the early careers opportunities that we created for people. We really did at this stage start to embrace the true DevOps culture. In 2018, cloud was declared within our organization as kind of like the preferred target. We wanted to start leveraging the benefits that the cloud could offer at scale for us as an organization. Many of our monolithic applications started to be are re-architected into microservices using RESTful APIs. This is a standard journey that I know a lot of teams have been on. Fast forward into 2020, this is a pivotal moment for Capital One, specifically in the US as an organization. We shut down all of our data centers in 2020 in the US. We had transitioned all of our application workloads into the cloud and became the first large bank in the US to do so. In 2021, more around this talk, this is where we started to look at commonality in how we build the software within our organization via these common CI/CD pipelines to start gaining more of the benefits. For 2022 and the future, well, for us specifically in the UK, it's about completing that cloud journey. It's about leveraging that common CI/CD toolchain to get our workloads completely transferred into the cloud. Okay. So I've talked about scale, I've talked about the complexity, and in the UK alone, we're reasonably significant scale. You can see on the screen we have over 70 development teams, there's 450 or so engineers, and they're supporting and operating over 500 applications. But that's not really the true picture of this. So across the organisation completely, we have over 1,000 tech delivery teams, and that's over 10,000 engineers supporting over 20,000 application components. It's really, really vast. So consistency at this scale becomes absolutely vital, especially when you operate in a financial industry like ourselves. Okay, so I've painted a picture of the ideal world scenario. I've talked a little bit about the tech journey in Capital One, but this has not been without its problems and challenges like any organisation. We're an ambitious organisation with significant investment in technology and desires for growth. And we've faced into many challenges on a day-to-day basis. So we started to see a lack of consistency in the way we build software. Our scale was creating challenges for us specifically. AWS native cloud capabilities, well, you can take those straight off the shelf, right, and deploy them into your application. It's really straightforward. But doing this in an efficient way that's both secure and compliant actually can become quite challenging. New security vulnerabilities, well, they're discovered almost on a daily basis in our industry, as I'm sure you all know. We wanted to eliminate our exposure to those completely across all of our environments. And we're financially regulated. We're regulated by both the OCC and in the UK by the FCA. So it's a duty to our customers to make sure that we can provide confidence that they can trust us. As you consider the scale of the company, it becomes much more complex to achieve all of these results. And in doing so, it leads to increased maintenance costs to run and maintain and secure the environment. Finally, well, we have competition, right? We have lots of competition. And in any industry, you can't stand still. And I think Kodak paints a really good example of that. We wanted to ensure that the products that we provide to our customers are everything they would expect and ensure that we're able to retain them and, importantly, grow our business. So as we defined where we wanted to have this common CI/CD pipeline, we created some boundaries for us and some criteria to make sure we could achieve this goal. Like I've already said, quality is absolutely key. We wanted to ensure that all of our teams were able to meet our high standard of quality with very little overhead. Things like automated testing, performance and integration testing, security scanning in the pipeline, automation of all of those cloud controls that I've touched upon. And where any of those controls did not meet our bar, the deployments would be blocked. They'd be stopped from being released into production to prevent us from releasing inadequate software into our environments. We want to ensure that the application developers can focus on building great functionality rather than focusing on how they deploy the latest AWS service in a compliant way. So ease of use was paramount. We don't have an unlimited budget to support our technology, much like most others. So the CI/CD platform, it had to be easy to maintain and support. You can't fulfill every single use case. However, through robust architectural standards, we wanted to ensure that the capability that we built as part of this pipeline was a good fit for the majority of our use cases. We'd also made some product choices in Capital One and some large investments into some CICD tooling. That all had to be integrated in this portfolio. Tools like Jenkins, Artifactory, GitHub, ServiceNow, and even Hygieia, which is the open source tool that was actually built within Capital One. So, specifically our CICD timeline, it started back in 2018 when we realized that a line of business had built a pipeline, and that was declared as our kind of North Star vision for what we wanted a great pipeline to look like. 2019, we started to see developer interest across all of our communities across the US and the UK. And in 2020, as an organization, that was the point where we declared we would start to align on this common platform. 2021, this was the pivotal moment for us in Capital One as part of this pipeline. It was declared mandatory. It was mandatory, which led to a huge migration effort for all lines of business, for every developer to migrate their pipelines onto this standard platform. And that did not come for free. But we really do truly believe that it's going to be a differentiator for us in the outer years. 2022 and beyond, well, actually in 2022, this journey is going to complete for us, and we're going to actually complete the program of work to migrate all of our workloads onto the common pipeline. So before I close and hand over to Paul, I was going to provide some high-level details and benefits that we've started to see already from teams that are using this technology, split across three broad categories. Firstly, efficiency. So with efficiency, we've started to align on the common pipeline. We've got a term about removing arbitrary uniqueness. It's where our engineers are improving the wheel rather than reinventing it. So crucial. And also the commonality of the pipeline is allowing our engineers to be more portable between teams too. Moving on to areas of DevOps and SecOps. So we're now really starting to see the prevention of vulnerabilities reaching production environments, alongside a large reduction in high-sev incident count too. Our engineers are able to swarm on issues collectively as a community to solve those problems. And most importantly, the application teams and the developers are spending more time writing application code rather than writing the code for the pipelines to deploy those applications. Finally, associate engagement, probably one of the most critical parts, right? So our engineers gain a true sense of building for the enterprise. So where a problem is solved, it's solved for everybody. And minutes saved in a pipeline by a very small code change actually saves thousands of hours globally for us across the entire enterprise. So that's it from me. I'm going to hand over to Paul now, and I think there's going to be a little bit of audience participation as a bit of an energizer. Thanks very much.
There is. So it's actually over to all of you now. So yeah, I've got a bit of a group exercise for you. It's quite a full audience, so this is going to be very interesting. If you don't want to participate, you don't have to, but it's a great activity I've got lined up. So Chris, if you just move on to the next slide, there's a few rules. So I have some cards at the front here, I have some paper, I have some pens. The only rule is, so some of you get into teams, so I suggest maybe some rows form a team and some people go individually. So if you know each other, get together into a team. So the rules is only one person can hold one of these cards at any one time. So these are in stacks. So in your individual or your team, work through that stack tasks of cards. You have to take the card from this table to your seat before you can work on the task that's on that card. And the cards also have to be worked in order. And to get you going and to give you an idea what it is, the first task is to draw a shape on a piece of paper. So go for it.
We're going to time box it to around 8 minutes. So if people could kind of get together, as I say, get forming lines and then come up to the front, take one stack of cards, just decide who you're going to work with. It's a bit of fun.
Yeah.
And it'll all come to light at the end. We need to decide how they take, which packs they're taken from, because they're going to.
Yeah.
Probably best to take the whole stack.
Yeah, if you want to take the whole stack, there are quite a lot of people. I'll let you improvise as you work through the tasks, but do not separate the cards if you take them away as a stack.
Yeah, the pack of cards can't be separated. There's a full list of tasks in there. Yeah.
As many sheets
as many sheets of paper as you like, pens, and one stack of activity pack.
You may find you need to come back for some more. You never know.
Can I work solid?
Yep, you can work solo if you want to work solo. That's absolutely fine. The stacks are there. They're the individual ones. Just take one of those packs.
Or multiple pens if you want multiple. There's no rules there. No rules. Yeah.
Yeah, if you want, a lot of people have taken a stack. If you want to take the whole stack, take it. But just separate one at a time. But yeah, enjoy.
the tasks here.
Oh, yeah, there. So you take one of these ones.
Take one of
look,
these packs here.
at the front. I should have hidden.
Yeah,
those
4
ones.
packs over here, yeah. Yeah. Apologies, someone may have taken one off the top.
I'll just hide these ones.
Start, absolutely, start.
Still
Yeah.
missing some. 1 and 2, 1 and 3.
One is on there. It's great to see some collaboration going on already in groups and between groups as well. Another 5 minutes, do you think? Till I gets 30. So we'll give it another 5 minutes. So I hope you're all getting on okay, no pressure. Don't forget, task 1 is on there, if you haven't done that one already. Hopefully you have by now.
Someone's completed it.
Sorry, I would just want to ask about the first task.
Draw a shape on a
shape.
paper.
Kind of shape I should draw before I proceed with the second.
Just as a shape, that's a requirement.
We've given you a requirement.
That's something to do, but not what to do.
Draw a shape.
Question that.
Just draw a shape.
Just
A
follow
shape.
the instruction and then carry on with
Yeah.
the task 2. Yeah, no problem.
Hello.
How did I go? Right. Was it okay?
Yeah, it's good, all right, I think.
As in my talk?
Yes.
Was
Yeah.
that okay?
It's brilliant. Yeah.
Okay.
Only had one person left. There was only one person left, so. Yeah. You're welcome.
Right, just a couple of minutes left.
Hopefully everyone's on about task 7 by now. We shall see.
Are there different
are.
colours? There are.
These
colours
are
here, yeah.
actually black pens, not red pens.
Interestingly, oh,
Well clarified on the requirements there.
I'm glad to see you were checking the requirements, though. Absolutely, yeah.
Make sure the measurements are precise if you've got that far.
Okay, quick question. Is it measurement millimeter, centimeter, or what? 210 is
Centimeters.
No, 210 millimeters.
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 It's millimeters. Thank you for the clarification. No, we don't have anything to measure.
okay.
It's they are actually black, not red. Yeah, that's red, but it is a black pen when you write with it. So that's blue. Yeah,
Okay, and nothing to measure.
nothing to measure.
Nothing
Well,
to measure.
nothing you can see that can measure. I will. Yeah, do best endeavours. Whatever
It
you
is
can come up
possible,
with.
though.
It is possible.
You can use mobile something.
I'll leave it up to you.
Yeah. If
Improvise.
yeah. Are you done? Can I have a
As
look?
people complete the task, if they want to bring it to the, do we want them to bring it to the front? How are we going to deal in it? Are they going to bring it to the front, or are they going to?
Oh, a team 1. Nice. So yeah, we have one team finished already. We have 2 minutes left. I'll just give you all a bit more time if you've not quite finished yet. I know some people have been asking how they might be able to measure something. We've had an interesting turn of events with the first submission here. The numbers do not lie. Just going to put this out there. If anybody wants any clues as to how someone else has done it, there is an example that you
What
can
do you need?
fit in a sourcing if you require it. Sorry? We do not have pencils.
You know,
We have,
hey, it's
they
a
are
real
black
world
pens.
scenario, right?
They're not red pens. And we have
We're
blue
in the
pens.
real world.
It's a greyish colour, yeah.
Yeah, it's grey color.
Yeah.
Okay. How do you get the grey color now?
I will leave
Right,
you
we've
to
got 1 minute.
interpret.
We've got 1 minute left, and we're going to wrap the exercise in 1 minute, and we'll just have a little conversation.
Oh, we have another one in. How did you find the measurements? I will reveal how you could have done that at the end, don't worry. Thank you. Right, we're probably in the last few seconds now. I don't know if that's probably changes after the minute. So yeah, if you start wrapping up, hopefully we've all found that fun, a bit more energized, ready for the second half of the talk. So I'm going to open for some questions in a minute if we have the microphone around somewhere, and just see how you all got on. So stick your hand up if you've got some feedback, how you found that exercise.
We've got some feedback over here, apparently.
Yeah, well, I want to hire your product owner. Is it possible to hire your product owner?
That would be me. Were there any particular issues you had with the requirements?
No, just the measurements.
Okay.
Yeah,
I can reveal how you could have achieved that
I think
if
it's
you want.
wrong on the fourth time. Yeah.
So if anybody's wondering how you actually get a triangle with the right dimensions, what you do is you take your piece of paper, you fold the first corner over, you fold the second corner over, and then when you unfold it, that triangle there is exactly the right dimensions that you were needing for this exercise. So it didn't have any submissions with the right ones. What was interesting is somebody wrote the dimensions on. When I've done this activity before, somebody wrote the RGB values on as well. So that's another way you could have probably met the requirement. Any more follow-up from yourself on that?
Oh, thank you. That's
Brilliant.
fine. Lovely.
Thank you for the question. Any more? If not, yeah, so it was great to see. Hopefully you saw some themes there, and we're going to lead into, that Chris has led into already. There weren't too many of you came up to clarify the requirements, but a few of you did. So I just want to imagine a scenario there where just one team was performing that exercise. They were close to myself as a product owner to clarify those requirements. They were very clear on what they needed to do. They didn't have as much tech debt on their piece of paper in achieving that, and what they could actually do is take that and give it to everybody through a photocopier, and then you could all achieve the exercise with the perfect triangle with the right dimensions and the right sizes. You could have even sent somebody out to get some colors to match the RGB values. So that is the value you can get in a single team, and then someone else could have worked on something else that was needed by me as a product owner as well. All you actually achieved was a couple of triangles between this big group in the room. But it's still great. And I hope you feel energized as well.
The clicker's just
You got the clicker?
Yep.
Is it that side?
Yep.
Cool. So we've covered the how did you get on. If anyone does have any more questions or anything, feel free to come to our booth at Capital One down there, and I can clarify some of the interesting parts of that activity as well. It leads into our CICD system. So the first thing we're going to talk about is how we're actually leveraging this to reduce our production outages of our services for our customers. So first of all, hopefully there's some of you in the room that are familiar with AWS, particularly the Route 53 service of AWS. What this actually offers is the ability to use health checks. So if you have two regional deployments, you can use health checks to say, is it healthy in this region? And if it isn't, it will automatically move your traffic over to the second region for you. So you might be asking, well, what more is needed? This is an AWS service. Everybody can utilize this. Why do you need a team to deliver some value in this area? So what we actually found with our services, particularly the large-scale services in the enterprise, is that what happened is the traffic shifted to the alternate region when there was a problem in the first region. And then there's no traffic hitting out of the region. So what happened is it thought it was healthy, and it moved the traffic back again to that region, and then it blipped again because the error is still there. And then the traffic moved back again. And it didn't really give the robustity we required in terms of checking if that service was healthy as well, because it only uses a health check. So what we did is we built some tooling around this, and we trialed it with a few applications, and it proved to really reduce our high severity incidents. So we rolled that out to all the other teams, and we saw a massive reduction in the incidents that we're seeing with this particular outages we're seeing in a single region. And everybody was able to leverage that one technology. It was written by a single team that had this great idea and proved it out with a couple of applications. The other way we're reducing our incidents in production is during deployment. So deploying new software is actually quite risky. No matter how much testing you do, until it goes into the wild and you've got your customers using it, you don't know how it's going to react. So what we've put into our CICD system is the ability to phase traffic as you're deploying it. So slowly and incrementally move the traffic over time to make sure and check for errors during a new deployment. If it doesn't see any, it will see it as successful. What we're actually doing as well is doing a single region at a time. So you're not taking both of your regions down at the same time and introducing issues into production. And then if any issues are seen, it automatically rolls itself back as well. So we see minimum impact to our customers. We can detect it really early if there is going to be a problem with that deployment. What this means for our engineers is they can deploy 24/7 because we have the confidence that if there is a problem, it'll have a minimal impact to our customers. It means no more late nights, no midnight deployments to make sure we're doing it when there's less traffic on the system. It also enforces backwards compatibility, because if you're phasing traffic to a new version of the application, you have to make sure that both versions will actually work at the same time to serve your customers. The other area we're leveraging to reduce our production instance is with monitoring. So we're automating this on behalf of our engineers with a minimum defined bar for monitoring. What this means is it saves our engineers time because it will create those dashboards, it will create those alerts for them. They don't need to research and find out what they need. If they want anything on top, they can do, but we set this minimum bar. And that gives us a consistency as well as a high bar to make sure we know that every service has a particular alert. What that enables is automatic recovery. So if any of these alerts happen, we can actually act off of that, automatically fail over to a single region, do a rollback, change some settings, whatever's needed, because we have that consistency with how applications are deployed and monitored. It enables to do this without needing an engineer to be called out to resolve it manually. And it's also tool agnostic. So if we change monitoring tools, we can do this en masse for all of our engineers instead of every engineer having to make that change themselves. The way we roll these kind of features out is initially customers, meaning our engineering teams, can opt in to this feature. We prove it out with that set of teams. And then when we actually see the value and we've proven it out, and we have the confidence, we change it to an opt-out. So if there's a particular application that can't leverage this particular tool for any reason because it's too risky, then we can actually opt out. We don't actually see many opt-outs of the technology though. Moving on, securing the cloud. So how do we ensure we enable those cloud controls that Chris was talking about? So firstly, we identify a need for a new cloud control. So this could be with an existing service we're using in the cloud or a new service that we want to use that we haven't used yet, or Amazon's just come up with a great new invention in the cloud and we really want to leverage it. So first we identify what controls we need. Then we update our tooling to meet those controls on behalf of all of our teams. And again, encouraging that inner sourcing and empowering our engineers and all those thousands of teams to actively contribute to this effort. Now, all our engineers to do is to redeploy. And then make sure that the cloud is secure and has the controls that we need in a timely fashion. Remediation of vulnerabilities. So I'm sure you all come across some vulnerabilities in engineering recently, if you're an engineer. So this is the way that it works usually. A new vulnerability is discovered. We wait for the vendor to release a new version of that software or that dependency package. And then every team has to go about updating that dependency, redeploying it into production to make sure that the environment is safe and secure once again. With these things, time is critical. Particularly if it's a zero-day exploit, we need to make sure we do that in a really quick and efficient time, and also have confidence that when it hits production, it's not going to cause any problems. What this means for teams is they have to drop any work that they're doing and reprioritize to swarm and focus on vulnerability remediation. Imagine a better way is to automate that. So in this flow that we're utilizing, a new vulnerability is discovered, a new version is released, and then automated processes update those dependencies and then roll that out into production on behalf of our engineering teams. They need to be aware this is happening. It takes very little focus from themselves and very little distraction to remediate these vulnerabilities. We have that assurance because, again, of that consistency and the automated testing that we're doing to make sure we know that software is working. Again, the phased deployment that we have in production makes sure if there are actually any problems when it gets into production environment, that we notice those and have a minimal impact to our customers, and we will roll back. We also rescan to ensure those vulnerabilities are remediated, and also we don't introduce any new ones. So Log4j is a great example where this actually really benefited our business. So I'm sure there's some in the audience aware it was a well-known zero-day vulnerability that came out. There was actually more than one patch, which was quite annoying for engineers that had to manually do this effort. So there's additional work for teams to keep on top of those patches and redo work they'd already done as well. The impact of this was both application code and infrastructure as well. So if you have monitoring applications, for example, installed on the EC2 machine, that was impacted by this. It literally impacted every single team across the enterprise, which is hundreds of teams, as Chris said, that we have there. So the remediation that we did for this, because we don't quite have that full roll into production for all our applications yet, we had that automatically dependency patching going on to bump the versions of libraries that are being used. It was a single-click release. It was a minimal effort to get into production for application code. However, it was something in the actual underlying infrastructure level on the AMI, the Amazon Machine Image. We did have automated patching for that. So teams didn't do any effort if they didn't have any application code and dependencies that was impacted. The outcome of that was a really quick remediation compared to those teams that aren't quite on this platform yet, and limited distraction for engineers. And they really valued having that automation there for them. And then finally, and then we'll lead on to some Q&A, embracing new technology. How we're able to use this, leading on to that use case of the cloud controls to enable new technology across the business. So AWS Fargate is a fairly new Amazon service, but being a regulatory industry, it does take a long time to enable this across an enterprise. So the way that we enable new services within our enterprise is we have our architecture will decide to use the service and it has value in their eyes to the business. And then our senior engineers decide the patterns for that. So how we're going to leverage this, where does it have value, what types of application does it service. And then at this point, we'll let all those teams in a source and contribute their fantastic and great ideas into this and help enable this for all teams in the enterprise. And this isn't just about deploying that infrastructure, enabling teams to utilize it in new or existing applications. It's also automating the migration to that. So where we see value with existing applications that might be running within Docker in ECS, for example, moving over to Fargate, which is serverless, has great benefits. So what I actually want to do is to automate that to enable everybody to move en masse once we've proven that out. And this goes on to how we roll these things out as well. We don't want to introduce risk into the business. We want to do it in a well-controlled way. So what we do is we do a pilot with low-risk applications first to prove out the value, shake out what isn't quite working. And then we continue with the feedback from those pilot users to then do an increased pilot with higher-risk applications, make sure that's working for all of our, before we roll it out to everybody. Then once we're happy and it's ready for general use, we then automatically migrate applications on behalf of our teams to the new platform so they can all leverage that and have great benefits. There are some decision points that we use along the way on this journey as well. So the various things that we do evaluate. So is evaluate service stability. So is it given stability of our applications we require, or are there certain problems and disruptions with this new service in the cloud that we don't want to put our business at risk from? We evaluate the cost savings. This isn't just the cost of running, but also the cost of maintenance. And what's the benefit in terms of cost to the business, as well as the performance of the service running on that. What does the deployment performance look like as well? Is it quicker to get code into production with this new service? And then finally, and most importantly, is the engineering experience. What are engineers thinking? Is it a great experience for that? Is it something we want to leverage? Is it difficult for them to use? Is it confusing? Is there anything we can do to make that journey better for them? And that's it. And that's how we're using this common platform to remove that arbitrary uniqueness, give consistency, and add some great benefits to the business and our engineers. If you do want to find out more and have some questions, come to the booth. I'll hand over to Chris for the...
No, thanks, Paul. Yeah, just to wrap, just to say thanks very much, Paul. If there is any Q&A now in the audience, happy to take questions. But as Paul says, if anyone's got any more information they want from us, then you can find us in the expo hall at the booth. Thank you very much.
Good morning.
Hi there. My question is, how did you go? So you know the pipeline for kind of discovering the vulnerability and then finding the vendor patch for that vulnerability and then starting to implement it in your services. Like, how did you go about detecting what the vendor released? Kind of, was there a standard way of doing that?
Yeah, it's a third-party tool that we leverage that can do all that discovery, and it runs in real time as well. So, you know, the engineers don't have to do anything to discover that; it's done automatically. So, it's a new vulnerability. It will pop up, say, "Hey, there's a new issue," and also say, "Hey, I'm taking care of it for you." So,
Okay, cool.
so say they have that awareness, but don't necessarily need to touch anything. Is where we're heading for. So.
Hi. So one pipeline, different application teams, and everyone can have different needs. And pipeline has multiple features. So how does individual team enable or disable a particular feature? For example, if I want to deploy a feature branch, which later I want, after testing, want to delete it automatically after some certain time. But other team can, they just want to deploy it, seeing deployment is successful, just delete it immediately so that feature can be merged into developer master. So if different teams needs to toggle between features, developer needs to do it manually in their some sort of pipeline guiding file, Jenkins file or something, or you have a tool for that?
Yes, this leads into a couple of things. So we do have shared patterns that we use. So, you know, if you do have an integration environment where you're testing stuff, there's ability to configure from a PR or a branch to have a separate environment in the cloud to run that against. And then everybody involved will follow that same pattern. So it has a common environment everyone's kind of testing against. And it's only when it goes into the main code base, it actually push all the way into production and impact everybody. And again, that testing ensures it doesn't actually have like a negative impact in terms of service stability and breaking changes. So,
Okay, thank you.
hopefully that answers your question.
Yeah.
Oh,
Just 1 second. There's just one other one at the back there.
Sorry. First of all, thank you very much. As you're in the financial business, I guess there is one or the other financial transactions involved. You said you shift your workload doing deployments gradually onto the same environment. What if the unexpected behavior of an issue or a bug happens? How do you address that with your stateful data, which is the transactions? When you roll back or something like that, how do you make sure the data is consistent?
So as well as looking at the application itself, and that is a good question, we're looking at how cloud technologies can enable us to have highly resilient data to make sure it's backed up regularly, make sure it's replicated across regions, across availability zones, particularly in AWS, and have abilities to sort of restore data. I believe the bit you're talking about is more if you change your schema, how do you roll that back? So we do look at that as well in terms of validating that the scheme is kind of like agreed by all parties as it's consuming that. We have ways to actually sort of roll back those data changes in terms of like schema changes, and we use feature toggles to make sure, you know, when we do make those changes, we're comfortable like the data structure is working, and we can turn that feature toggle on, which actually change the data that goes in there, so we make sure we're considering rollback in terms of like data structures as well.
Thank you. I think there's a question just at the front.
You mentioned automatical patching regarding Log4j vulnerabilities, if I understood you correctly. So I was just curious how you did this, how you automatically patched your applications. I mean, this is a manual task for developers to bring new dependency, or some other approach.
Yeah, so there's multiple ways. So if it's just a dependency and it's like a minor bump, something like that, we do have sort of external tooling that we can leverage, which does that automatically, because we have the confidence in the pipeline when it's on a PR branch to know everything is working when it's deployed without issues. But have that confidence in that set. If it's something a bit more major, we do have other ways. It needs it does need an engineer to look at it. We have a centralized team that can do that on behalf of the enterprise. So they'll look at common patterns, how people are using stuff. Like if a class name needs to be changed, we can run sort of algorithms, that kind of stuff to say, this is what we think needs to happen, and script that, roll that out to a subset of repositories, make sure it's working, identify the code bases that are impacted, and then run like a trial on, I say, a subset, and then roll it out to everybody. So we'd have various strategies for doing that. So not every team has to do it. We can have one common way of doing that, and again, that consistency is key. So make sure if it's an API that's in Java, everybody use Spring, use the same version of Spring. It makes it a lot easier to do that kind of thing, to have those common patterns. It's hard to get to that point, but once you're there, it's a lot easier, which is why it's been a multi-year journey. Hopefully that answers the question. Yeah. And we continue investing in finding new ways as well. It doesn't cover every use case, so where we do find it isn't quite working, we'll look to see what we can do. And this is the value we're investing in that as well. And if it's a very small percentage, it might not be worth investing in, so. Or at least not right now. Any more questions? Cool, fantastic.
Thanks very much.
If you do think of anything else, come to our booth.
Thanks.